Hello there, good morning. So today we are going to be working on domain and range. We were just talking about area and perimeter of polygons and our linear functions. So we're going to move into what is domain and range, how can we find it, what are the different ways that we can see it, and how can we use it. So we're kind of moving into a new topic. So I want to show you guys what domain and range is and how we can use it with our polygons and find an interval of a domain and an interval of a range. Now there's different ways that we're going to see this, but the first one I want to look at is going to be intervals for sure. I'm going to show you all the ways today in your notes, and then tomorrow we're going to look at intervals with polygons. So introduction to domain and range. Domain is all of the x values in a set of ordered pairs. It could be all of the x values in a table, all of the x values in a map, or all of the x values in a graph. So you're going to fill in a graph right there. Okay, so I'm going to show you the different ways that you can see this. And as I always say, if I'm going too fast or you need to pause the video while you're filling in your notes, feel free to do so at any time. So these are ordered pairs right here. I know that you guys have seen ordered pairs before. We've used ordered pairs when finding endpoints, midpoint, using ordered pairs to find the distance of a line between 2 points. We've also looked at the coordinate plane and plotting points and all of those things. So this is a set of points, and to find the domain of those points, you're only talking about the x values. So the x value in this point is the 2. Now we know when we look at all of this, this is my x and this is my y every time. You can label it, this is the first set, this is the second set, this is the third set. You can use those x1, y1, x2, y2, x3, y3, you can keep going. These are the x values in the front and the y values in the back. So to just write down the domains, you're going to use this butterfly parentheses. This is called set notation. And you're just going to write down the x values. Make sure you start with the smallest number and go up. So it's 2, 3, and 8. They happen to be in order for us. If you had written this with just regular parentheses, it's going to be a little confusing. We do regular parentheses for ordered pairs with 2 numbers. When you're talking about multiple numbers, we're going to use this type of notation. Everything that we write and the way we write it is very important in math. It tells us things. So this is the domain of all of these ordered pairs. We have a domain of 2, 3, and 8. That means those are the points, the x values, that these points are touching or going through. You may also see a graph given to you with points on the graph, and it may say, what is the domain of this graph? Well, if it's just 2 points, again, this is an ordered pair of 4, 0. This is an ordered pair of 1, 4, right? So it's over 1, up 4. That's the coordinate of that point. Over 4, up and down 9. That's the coordinate of this point. So we're looking at these 2 ordered pairs. The domain is just 1 and 4. It's the numbers, the x values that those points go through. Just 1 and 4. And again, make sure you use that set notation so that we know. You may also see it in a table. So if you've got a table of numbers, and I know we looked at this in our linear functions, and we found the difference in the x's and the difference in the y's, and we could figure out our slope that way. But if you're given a table of numbers, all the numbers underneath the x, those are your domains, and you can write them this way. And then the last one is to look at an interval of domain and range. So when we have polygons on the coordinate plane, and I say, what is the domain of the shape, or what is the range of this shape? That means how far on the x-axis or how far on the y-axis does this polygon cover? So if we look at this triangle that was plotted, and I say, what is the domain? Well, we know that domain is the x values, so we're going to be looking at our x-axis. So across this x-axis, how far does this triangle touch? Well, it goes all the way over to 2, and it goes all the way over to 4. And what I like to do is draw a dotted line that cuts through the x-axis, the furthest point left and the furthest point right of my shape, so that I can shade in all of that area as far out as my shape possibly goes, and then see what numbers does it get to. Well, this triangle goes all the way out to the 2, and it goes all the way out to the 4. It doesn't go any wider, so on the x-axis it's covering between 2 and 4. So when we're talking about an interval, you have to use this notation. X is in the middle, and then you've got these symbols. This is less than or greater than. And you put it on both sides. So it basically means X is bigger than this number, smaller than this number, hence why it's in the middle. So this shape is in the middle of these two numbers, 2 and 4, which means any X value bigger than 2 but less than 4 is where you will find this polygon. So anything bigger than 2, so like 2, 2.1, 2.2, 2.2, 3, 2.4, 2.5, all the way up to 3, all the way up to 4, but nothing bigger than 4. It has to be less than 4, but bigger than 2. So anywhere in there, you'll find the shape. And so that's an interval. And then we're also going to look at range real quick for your notes today. So these notes aren't too hard. You're just filling them in. Just make sure that you're understanding the concept that we're covering here. So let's look at the range real quick. It's the same thing, but now we're going to be talking about the y-axis. So what is range? Range is the y values in a set of ordered pairs, or the y values in a table, or the y values in a map, or the y values in a graph, right? So if you have some ordered pairs here, right? This is a point on the coordinate plane. This is a point on the coordinate plane, as well as this. The range of these 3 points, or the y values that are included, are 8, 2, and 3. But remember, we write these from least to greatest. So I'm going to put the 2 first, then 3, then 8. And those are the ranges for these ordered pairs. Make sure we use a different type of parenthesis here so that we know what we're talking about. Another example is you may see points plotted on a coordinate plane. So figure out what those points, the ordered pair is for each point, and then you can write the ranges separately. So the coordinate point for this, the ordered pair for this point is 1, 2, 3, 4, over 4, up and down 9. So it's 4, 0. And then the ordered pair for this point is over 2, up 2. So it's 2, 2. So this is the ordered pair. We're going to pull out just the ranges, which is just those y values, starting with the smallest number, which is 0, and then 2. So 0 and 2 are the y values that these 2 points are touching. They're touching 0 on the y-axis, and it's touching 2 on the y-axis. Another way is you may see a table, and again, any number under the y in your table are y values. And you may also see a shape. So in this graph, I have a square, right? And what I did is, if I'm looking for the range, instead of shading up and down, cutting through that x-axis and saying, oh, how far does it go on the x-axis? It goes over this far and this far. We're talking about the range. So we're looking at the y-axis. Okay, so I need to know how far on this y-axis, what would this polygon touch? If I were to scoot it over and touch the y-axis, what numbers would it go through? So this square goes all the way up to the 4 on the y-axis, and it goes all the way down to the 2 on the y-axis. And what I did is I just drew lines to get me over to the y-axis, and then I just shaded it in and said, okay, what are these numbers going up to and down to? It goes up to 4 and down to 2. So when I come over here, I'll put the y in the middle because we're talking about range, and I have to put these symbols on both sides. So it's going to be less than this number, but greater than this number. What's the smallest number? 2. And the biggest number is 4. You have to put the smallest on the left and the biggest on the right because of the way that these symbols are pointing. The y is greater than 2. You see how it's open to the y? It's bigger on the y. The y is greater than 2, which is true. Anything bigger than 2 on the y-axis. But also any y value that's less than 4. So it has to be less than 4, but greater than 2. And it'll fit right in here, which is true. So this is the kind of notation that we're going to be looking at first. And we're going to do that in tomorrow's notes. So for today, just make sure that you copied this down, and if you need any more help with this, you can always go to Khan Academy, that's Khan Academy, and just type in interval notation of domain and range. So this is interval notation. Or you can YouTube domain and range of polygons, domain and range of shapes on the coordinate plane. You can always look things up if you're still confused on them. Or you can email me and we can set up a Zoom and I can explain things further. But this is your notes for today on Introduction to Domain and Range, which is the X values or the Y values that are given to you. And they may look different and they may be given to you in different forms, but it's all the same thing. Let me also add real quick before I end this video. Domain and range is just another way to say X and Y, or input and output. And so we've been working with multi-step equations where I say solve for X and you have to get X by itself, or solve for Y and you have to get Y by itself. So we've already been working with X and Y's where our equation has an X and a Y in it. And that's going to be helpful as we move into other things that we're about to get into. So domain and range is just another way to say X and Y, and you've seen that in some of your equations already. And these are different ways that you may see it moving forward. So make sure that you get these copied down. It's going to be helpful for tomorrow's notes. Good job today, guys.